Hello. Am I audible to all?
Yes, sir.
Okay.
सर ते
Let me.
बी पासून लोड पर्यंत 1 मीटर आहे सर.
Please tell me.
सपोर्ट सी पासून लोड पर्यंत 3 मीटर आहे सर अँड
Wait,
देन
wait,
ई
wait.
टू बी 1 मीटर आहे सर स्पॅन.
हाँ. बोला.
सर ते स्पॅन सर टोटल 3 नाही आहे सर 1 + 3 आहे सर.
Span.
इकडचं डी डी ते सी पर्यंत सर.
आवाज येत नाही, थोडंसं मोठ्याने बोला.
सर ते स्पॅन सर डी टू सी
Span
4 आहे सर
4
टोटल.
meter. 4 meter for AB and for BC 3 meter and the column particular span AB is 20 kilonewton per meter and the load sorry this particular load I just check whether the load is exactly on. Okay, 3 meter is up to this particular point and 1 meter from the B support. Okay, once again you just correct it. At exact at point B, the load is placed. This particular load is placed 1 meter from B support. So and 3 meter from the C support. So you just make it correct. Okay. Is it correct?
Yes, sir.
Okay. We'll take first step then. Am I audible to all?
Yes, sir. Yes, sir.
Am I audible to all? Please let me know.
Yes, sir.
Yes. Okay. Thank you. Then first step. What is the first step? Find DKI.
DK.
Okay. Degree of kinematic indeterminacy. For this particular frame, this is not a what you can say the loop frame. This is the open loop frame. So we directly take it as dk is equal to the same formula. We can use it for this number of joint multiplied by degrees of freedom minus reaction. Okay, we'll have the 4 possible joints are available here, A, B, C, D. Therefore, for each node, we consider the degrees of freedoms are 3 minus reaction. Reaction, how much reaction is present here? You just see for the support A, which is exactly fixed support, and at D, here also the fixed support. For fixed support, we are considering 3 reactions, 2 translation and 1 rotation. And at D, 2 translation, 1 rotation. And here, 2 translations we are considering at horizontal as well as the vertical. For the hinge support, we are considering the 2 reactions, 3 plus 3, 6 plus 8 number of reactions. Okay, 12 minus 8 equal to 4. How we get the 4? You just see here A and D are fixed, but B and C are only the pin jointed, or we can call it as a semi-rigid joint. So for this sake, this particular joint is moving in the rightward side or the upward side, or this particular joint is moving in the this particular fashion in the horizontal direction or the vertical direction. Okay, so prevent that, you need to understand here. You see this particular joint here, only theta is present because this is the intermediate joint. So only if you consider the bending profile of this particular beam, it will look like this. Or we call it as a simply the deflection profile. With the after applying the force, it will deflected like this. Okay. Okay. So for the sake of simplicity, we consider here theta b and here also theta b, and here only we get a theta c. Therefore, if you want to create this support as a fixed support, you need to introduce one rotation here. This is constraint 2, I must say. Then if you want to fix it, this particular joint, you need arithmetic indeterminacy for this structure is 4 minus 2 equal to 2, and available unknowns theta b and theta c. Are you getting this point? If you have any doubt regarding this, you can ask, unmute yourself and ask. Okay. Otherwise, I'm just considering that you are getting all the points correctly. ओके, ह्याच्यात कोणाला काय डाऊट आहे का? थीटा बी आणि थीटा सी कसं आलं? सिंपल वे मध्ये लक्षात ठेवा, जर तुम्हाला एखादा अननोन जॉइंट आहे त्या ठिकाणचं तुम्हाला डिस्प्लेसमेंट पाहिजे आहे किंवा रोटेशन पाहिजे आहे, आता या ठिकाणी स्लोप प्रेझेंट असणार आहे. बिकॉज ऑफ दिस पर्टिक्युलर लोड इथं स्लोप प्रेझेंट असणार आहे, इथं पण स्लोप प्रेझेंट असणार आहे, आणि इकडं आपल्याला स्लोप आपल्याला काढायला लागेल. ओके, जर समजा इथं ओव्हरहँग असेल तर तिथं डिस्प्लेसमेंट आला असता. ओव्हरहँग नाहीये तर त्यामुळे त्या ठिकाणी डिस्प्लेसमेंट आपल्याला कन्सिडर करायचं नाही. सो वी आर हॅव्हिंग this particular joint is of what you can say here theta b and theta c is unknown. So directly you just see this particular dki. Dki is equal to किती आला मग? We have dki is equal to 2 theta b and theta c. Okay. Then next, after finding out the dki, what should we have to find then?
Fixed end moment, sir.
Okay, please. Step number 2, find
Fixed end moment, sir.
P matrix. Okay, find P matrix. Okay, find P matrix or fixed end moment. Fixed end moment. Okay, simple way. You just consider span AB. You make sure that this particular joints keeping at fixed. Try to find out the fixed end moment for this. The problem itself, 20 kilonewton meter load is there. 2I, and here 4 meter is the length. You just take it down. Okay. For getting the fixed end moment MFAB, exactly WL square by 12. Okay. Find out. If you have the calculator with you, then find out.
26.67, sir.
6.67.
I'm not audible your voice. Instead of that, you just put a comment. Okay. 26.67 kilonewton meter minus MFBA. Okay. WL square by 12. Exactly 26.67 kilonewton meter. Okay. This is for span AB. For span BC, again you have to calculate the fixed end moment for this. Here, how much is the load? I'll just once again recall this particular problem. Okay, 90 kilonewton load is there. Okay, 90 kilonewton load is there. You just take and 3 meter from C. BC. So try to find out MF BC then. Okay, this is the MFBC. What is the formula for finding out MFBC?
WAB square upon L square.
WAB square upon L square, correct. Here, W is equal to 90 multiplied by A, 1 multiplied by 3 square divided by L square. Total L 4 meter. Okay. Try to find out. Okay. The calculator with you. Do your own calculations. When you are doing your own calculation, then only you can understand the problem well. Okay, correct. 50.625 kilonewton meter. Exactly. For FFCB then, okay, plus WA square B upon L square. WA square B upon L square. You just again write it down. 90 multiplied by 1 square multiplied by 3 divided by 4 square. You will get exactly the answer for this. 90 multiplied by 1 square multiplied by 3 divided by 4 square. It works out to be 16.81, correct? 87 or 81. Okay, right. Kilonewton meter. CB. Okay. In the problem, there is no any such type of horizontal force on BC or the UDL is present on PD. So, skipping the fixed end moment for BD. So, you just write down fixed end moment for BD is equal to fixed end moment for DB equals to 0. Because no load is available on BD. Up till now, it is correct. Then followed with the next step. Okay. P1, right? P1 then. How will you write the P1? Here it is the coordinate at P1. So for calculating P1, you need to consider this particular point B, which is having combination of BA, BC, and BD. You just add the fixed end moment BA, fixed end moment BC, and fixed end moment BD. But for P1, we'll directly take it as MF BA plus MF BC plus MF BD. But this is 0. Only thing is present MFBA. MFBA how much? Okay, we'll take it as 26.67 minus MFBC. Already you worked out here, minus 50 minus 50.627 625. Okay, here it is 0. So work out P1 then 26.67 minus 50.625. It works out to be how much? 23.955. Okay, this is the P1 which will only you have to take exactly P2 is equal to how much? P2 is equal to MF CB. Directly you just put P2 is equal to CB. MFCB. MFCB, how much it is? Okay, 16.78. Okay, Newton, kilonewton meter. This is also kilonewton meter. Okay, we'll get the P matrix with the help of this. We can write P1, P2 here. P1 is equal to 23.955 and P2 is equal to 16.87. This way you have to get the P matrix. Then step 3. Once again recall all the previous lectures. Find
K matrix.
K matrix. Okay, correct. K matrix. K 2 by 2. We have to find out the K matrix. For the sake of our convenience, we take it as theta P and theta C. So these are the two unknowns. We can find it out. Okay. For finding out the coefficients of matrix, apply unit rotation at B. First you have to apply the unit rotation at B. For this, you take this frame once again. Okay, whether we are visible or not, please let me know. Otherwise, it will be very difficult to me to understand. Okay, this is the problem. 4 meter. Okay, I, 2I, okay, A, B, C, D. Here also you will have the 4 meter. Here also you are having the 4 meter span. Okay. I'm just applying unit rotation here. Okay. After applying unit rotation at B, this particular frame is deflected like this. Okay, you just see I'm just applying unit rotation. You need to twist here. Okay. When you apply the unit rotation at B location, this particular frame is deflected like this. Okay. And here we'll get the theta B value. Okay, theta B. I'm just applying theta B unit rotation equal to 1 or moment equal to 1. Okay. So for the sake of this, you can find out the K11. Okay. Simple way for finding out K11 is equal to how much? You just take here 4 EI by L, 4 EI by L, 4 EI by L. Okay. The 4 EI by L for AB, 4 EI by L for BC, for 4 EI by L for BD. Sorry, BD. Are you getting this particular point? Okay, see, after applying unit rotation, the moment is exerted at that particular moment is nothing but 4 EI by L. And 4 EI by L, you have to add it for this particular joint. 4 EI by L for AB, 4 EI by L for BC, and 4 EI divided by L equals to BD. So you just try to find out 4 multiplied by 2 EI divided by L is 4. Okay. Plus here 4 multiplied by 2 EI divided by L, again it is 4. And here it is given as a I, only I. So you just take it as moment of inertia is I, and again this is 4. How much it works out to be? Please let me know.
5
EI, sir.
5 EI, sir.
5 EI. Okay, 5 EI. 5 EI. Because here 4 multiplied by 2 equal to 8 divided by 4, 2. Here 2 and here is 1. Therefore, it is works out to be 5 EI. Okay. That is, you are understood the concept well. Then try to find out the second coefficient K21. K21 exactly the moment here which is exerted here, and this moment is nothing but how much? Okay, this particular moment is nothing but 2 EI by L for BC. For BC. Simple way, 2 divided by 2 multiplied by 2 EI divided by 4. How much it was to be? EI.
1.
EI. Then for getting the second column, applying unit rotation, C point, coordinate location 2. Okay, C point. I'm just applying unit rotation to coordinate location 2. For that sake, I'm just trying to again draw this particular frame. I'm just applying unit rotation here. After applying unit rotation, keep all the other joints fixed. Okay. Here, this is the deflected profile. A, B, C, D. Here 4 meter, 2I. Here it is I. So it is works out to be how much? K 1 2 equal to how much? Here it is 4 EI divided by L. If it is 4 EI, then half of this 2 EI by L. So this is 2 EI by L equal to 2 multiplied by 2 EI divided by L equal to 4 equal to EI.
Yeah.
Then K22 is equal to exactly this particular moment is 4 EI by L. 4 divided by 4 into 2
2 EI.
EI divided by 4 equal to how much?
2 EI, sir.
2 EI. Okay. Here completes our matrices. Okay, you just try to draw the matrix then, or write the matrix with you. 5 EI, EI, here EI, and 2 EI. Okay, here completes the matrix. Then next find out next step number 4. Find
Unknowns.
theta B,
This equation.
theta C. Using stiffness
Slope and
equation.
deflection.
Slope deflection, sorry, stiffness equation. What is stiffness equation?
K is equals to
P is equal to
Equals to K delta. Okay, here P1, P2 equals to K11, K12, K21, K22 multiplied by theta B, theta C. You just try to tell me P1. Here is the P1, which you are already getting from fixed end moment. This is P1. Okay, P1 and P2. 23 point minus 23.95 and 16.87 equals to, write down the K matrix which we already written on the previous steps. Okay, we just write down here EI, EI, 2 EI. Let me know the equation then. 2395 equals to 0.5 EI theta B plus theta C EI. This is equation number 1. Then followed with the second, okay, plus 16.87 theta B, EI theta B, EI theta B plus 2 EI theta C. Okay, one at the same. These are the two unknowns, or equation number 1 and 2. Sorry, equation number 1 and 2. Try to solve this equation and find out theta B and theta C. How much is the theta B and theta C? Okay, use two
Minus
simultaneous
7.1898.
for the equation mode. You have to take equation with two unknowns. For A1, you just type 5. For B1, 1, C1 minus 23.95 for A1 1 A2 1, B2 2, and C2 16.87. How much it works out to be? Okay, right.
That's 7.198.
96 divided by EI, and here theta C equal to 11 point, okay, 11.9 or 12 exactly. Correct. Here is the answer. Theta B and theta C we already worked out. Then next step is to find out final moments using slope and deflection equation. Find, okay, step number 5. Step number 5. Find final moments using slope and deflection equation. What is the slope and deflection equation? You have to write MAB for MAB, MFAB plus 2 theta A plus theta B minus 3 delta upon L. But here no delta is present, so you just neglect this particular delta. Only you have to keep this equation. Okay, so after putting all the values, you will get exactly MFAB 26.67 multiplied by, here I is 2, therefore 2 EI divided by L equal to 4. Here theta A is also 0 because fixed support. Only thing is present theta B. How much is theta B? Theta B already you worked it out, minus 7.196 EI. EI get cancelled. Only thing MAB is remaining. Okay, try to find out MAB then. Okay, do your own calculations. I am insisting you. Why? Because without doing calculation, you cannot solve this particular problem. Okay, minus, correct, minus
33.866.
33.86 kilonewton meter. Okay. All of are getting the same results, the same value. Please check. Okay, correct. MAB equal to this much. Okay. Finally, then next you have to find out MBA. Then the same formula you have to use, MFBA plus 2EI divided by, 2EI divided by L into 2 theta B plus theta A. Okay, here theta is absent because this is 0, fixed beam is there, and you have to use MFAB is equal to 26. Okay, 26.67 plus 2 into 2 EI divided by L equal to 4, 2 theta B minus 7.196 divided by EI. How much it works out to be? Please let me know. MABA. Okay, try to calculate at your own. 2 multiplied by 7.1.
12.27, sir.
how much? Okay,
278, sir.
27 kilonewton
278.
meter. Correct. Okay, exactly. We'll get this particular moment. Then find out the moment which is exerted MBC then using the same equation MFBC plus 2EI divided by L into bracket 2 theta C. Okay, here theta B and theta C are already we worked out. You just put the value of theta B and theta C and MFBC. Here MFBC we already worked out in the fixed debt moment. Okay, for MFBC minus 50.625 plus 2 multiplied by 2 into EI divided by L equal to 4, theta B equal to 7.196, okay, plus theta C equal to how much? Theta C equal to
11.
Theta C we worked out. Okay, theta C is equal to 12. Okay, please let me know MBC then. MBC equal to 48 point, okay, 284. Correct. Whether you are getting the same value or not. Please check. Okay. After this, for MCB, you just work out MCB. It will exactly 0. It is works out to be 0. Okay. Check whether you are getting the 0 value or not. Okay. Use same equation. MFCB plus 2EI divided by L into 2 theta B. Okay, here it completes the equation. Okay, MFBC, MFCB how much? Okay, MFCB, here is MFCB 16.887 plus 2 multiplied by 2 EI divided by L equal to 4, 2 theta 2 into 12 plus or minus 7.196. Okay, please check whether you are getting zero answer, because at the simply supported end the moment is 0. Simply supported end moment 0. Okay, please check whether this particular equation gives a exactly 0 answer or not. Okay, calculator is with me. You just check your answer with the help of your calculator. Exactly, it is works out to be how much? 16.87 minus 16.804. It works out to be around 0.00 something, but exactly it works out to be 0, because as the way stated that this particular support is simply support, so at the simply supported end moment is 0. Are you getting this particular point? Then followed with the BD and M moment M BD is equal to, exactly you have to use MF BD plus 2EI divided by L into 2 theta B plus theta D. Here theta D is 0, theta B is present. Here also it is 0. MFBD you worked out with the help of this 2 multiplied by EI, okay, multiplied by EI divided by L equal to 4, and here 2 multiplied by 7.195. How much it was out to be? Please let me know. Okay, exactly. It is works out to be same.
7.196
kilonewton meter. Here M dB then, okay, 2 EI divided by L. Already it is 0, therefore I am not considering this, only theta B you should consider here. Okay, 2 divided by 4 EI. Okay, here theta B equal to how much? Theta B is works out to be how much? Minus
3.599.
okay, how much?
3.599.
Okay, 0.5 multiplied by 7.1, 3.5 minus kilonewton. Okay, this way you have to calculate the fixed end moment. After this, we need to draw the bending moment diagram, which is very quite simple to draw the bending moment diagram for this type of the frame. Okay, first of all, try to draw a simply supported bending moment diagram. For this, you are having the loading as well as the, what you can say, the span is available. How much is the load? See this particular problem once again. Okay, see the first problem. Okay, this is the problem which is having 20 kilonewton meter load on the UDL which is present, and exactly 90 kilonewton load which is available 1 meter from the B support and on the span BC. So you just directly draw the bending moment diagram. Exactly we get the bending moment diagram here is the parabolical shape. Okay, and the bending moment diagram for simply supported W square by 8. For eccentrically placed load, you will get the bending moment diagram. This is a standard case. We already studied in our previous lectures. For getting the simply supported bending moment diagram for the point load, eccentric point load WAB by L. This is the A, this is the AB. So you will just find out this particular movements first. Okay, what is the movement here? 20 multiplied by the span 4 meter. Here also you are having 4 meter, and here also you are having 4 meter. But here 1 meter A and 3 meter B. So try to find out the movements then. Please let me know. Okay, first of all, find out this particular UDL movement, maximum bending moment, which is occurred at exactly center. W equal to 20 multiplied by L square. L square how much? 4 square divided by 8. It works out to be 40. Okay, 40 kilonewton meter. And here 90 kilonewton load is there. 90 multiplied by A, 4 multiplied by 3 divided by 4. WAB by L equals to 67.5. Okay, correct? Okay, right. 40 and 67.5 will get the simply supported bending moment diagram. You just overlap these movements which we get with the help of the stiffness matrix method. Okay, you just overlap that particular movement on the simply supported bending moment diagram. Here is the 33. Exactly, we'll get a 33. Okay, 33 here, and for AB you will get 12, and for BC you will get 48. Here is the 12. We just join it using. Okay. For the sake of simplicity, I am just drawing once again this particular frame. Otherwise, it will be difficult me to explain. Okay. Proportionate diagram you have to draw. Okay, 33 here, 12 here, again 48 here, 67, 48, 12. You just try to connect this one, then at this location CB you will get a zero moment. You directly join it here because at this particular location hinge support is there, and for this sake you just try to recollect the moment here 7.195, and here you will get exactly 3.5. Yeah, this is the consecutive bending moment diagram. You just hatch the uncommon part which is available here. See, this is the uncommon part, or this is the consecutive bending moment diagram. Okay, only the hatch portion we are using for our calculation. Okay, see this particular. Okay, this is the bending moment diagram, BMD. Okay, you just see whether we are getting the same result or not. Okay, see, with the help of this method, we'll getting the same result or not. I'm just presenting my screen. Okay, how much it works out to be? Okay, 22 kilonewton meter, 36 kilonewton meter for PA, and 4.67 kilonewton for PD, and for right. Recollect these answers whether we are getting the same result or not. Method is there to validate whether we are getting the same result or not. Okay, how will we get that particular? We'll see it. Okay, am I audible to all? Please give me 2-3 minutes. We'll finish it off. Okay, whether you are visible my screen?
Yes, sir.
because somewhat the answers are not matching. So we'll try to find out these answers with the help of software. You just see whether we are getting the same results with the help of software or not. Okay, this is the problem which we already taken for the analysis purpose. Okay, I will just minimize this particular problem and try to model this beam on the computer software StatPro. Whether we get the same result or not, we'll check it here. Because sometimes the book problem and they using the methods are different what we are taught in the this particular C. I'm just putting whether you are visible the screen. Let me know. I'm just finishing this particular lecture within 2-3 minutes. Try to be there. This is the graphic user interface of StatPro. Okay, I'm just modeling this particular beam problem, frame problem on the STAD itself. Okay. I'm just applying the property to this particular beam as well as the column. Okay, try to be there in the meeting itself. I am creating the supports here, pin jointed support. I am creating. Member load, which is exactly 20 kilonewton load. You have to add for the concentrated force, which is exactly present at 90 kilonewton, which is exactly present at 1 meter from support. I'm just assigning these loads on this particular frame. Okay. Have you seen this particular problem? Please unmute yourself and tell me whether you are visible the screen. It will require hardly 2-3 minutes to complete. Okay, this is the problem which we already discussed in the classical approach. This model is ready for the analysis purpose. Okay, I'm just going with a fast forward. Okay, this is the bending moment diagram, which is showing here exactly, which will we get from the software as well as the classical approach. Exactly same bending moment will occur here. We'll just see whether we are getting the same result or not. Okay, view value beam result max or end moment. We'll just take end moment or not. Okay, exactly 26.1129. How much we get? Okay, MBA here for this particular model case, MBA, how much it works out to be?
12.
What is happening here? Okay. See, 26.129 at 38. Some of the calculations mistakes we done in the to solve the problem. You just recollect that particular problem once again and try to find out, okay, the exact answers. These answers are nearby the software answer. Okay, BD it is works out to be 4.64. Okay, we'll try to get the answers once again. If it is the procedure is correct, no doubt. One more problem we have to solve with the help of the stiffness matrix method, and we'll get the answers correctly. Okay. The values are very much near to which we are solving with the help of classical approach, and the software are nearly same. So this is the way to what you can say, validate the problem, whether you are getting the same result or not. Okay, are you getting this particular point? Shall we stop here? Okay, you are already having one more lecture to. Okay, I'm just stopping this particular presentation. You may 2-3 minutes will try to recollect once again. Okay, Pallavi Maitre, are you there?
Sir.
Afrin, Pravalika,
Yes.
Pravina,
Present, sir.
Shri Salunke, Pawan Kumar Soma. Okay,
Yes, sir.
all are listening. This particular already I have taken the online presenting. You just leave this particular meeting. We'll again try to meet in the successful lectures. So with this word, I just conclude this particular session. One by one, left this meeting. And today itself, I am just giving all the problems for the assignment number 1, and I will just sharing this assignment number on WhatsApp group. So try to correct that assignment and try to solve. Okay, thank you once again.